Generalized permutations and combinations. So permutations and combinations that involves picking things with no repeats, right? What happens if we're allowed to have repeats? So example one, retail, right? I've got a set of how many symbols there? 1, 2, 3, 4, 5, 6 symbols. How many different strings can I make out of those 6 symbols? 2, 3, 4, 5, 6. R-E-T-A-I-L. Right, if we're just using those 6 letters, you have 6 choices for the first, 5 for the second, 4 for the third, 3, 2, 1. So 720 possibilities. What about coffee? Now, coffee is different from retail in that there's 2 Fs, but you can't tell the difference between the 2 Fs, right? In retail, you can tell the difference between the T and the A, for example, or between the I and the L because they're different letters. But here we have an F that is used twice. So coffee a little bit different because now we're saying instead of here are 6 letters, choose them, we're saying there are 4 letters, C-O-F-E, but we want to use F twice and E twice. And how many different ways are there to do that? Well, again, we have 6 strings. We have 6 spaces. We have to use the Fs, right? We've got 2 Fs. Pick 2 of the spaces and put your 2 Fs in there. So you're picking 2 spaces out of 6 for the 2 Fs. And then you place the 2 Es. And note, once you place the 2 Fs, now you only have 4 spaces available, right? Because you've got 6 spaces total, you put in 2 Fs, and you have 4 spaces left, and you place the 2 Es, so C42. And then you can place 1 O. You've got 2 spaces left, and so you can place that. And then you place your 1, what's the other letter? C. You have 1 space left and you put that in there. And so that's the number of ways to do it. Multiply these together because it's a sequence. First this, and then this, and then this. You place your 2 Fs, and then you place your 2 Es, and then you place your 1, 0, and then you place your 1 C. So the answer becomes C62 times C42 times C21 times C11. So that's the answer. Okay. So it's not too bad, right? If you have repetitions, you just, put in the highest number of letters first, right? 2 Fs into 6 spaces. That leaves you with 4 spaces, and then put in the 2 Es, et cetera, et cetera. Note that if we actually multiply this together, and I'm not often going to pull out the formulas, but I want to explain where this formula in the book comes from. What is this? This is 6 factorial over 4 factorial times 2 factorial. That's what this number is. This number is 4 factorial over 4 factorial times 2 factorial. The denominator is the 2 and then the 6 minus 2. So 6 minus 2 is 4, 4 factorial and 2 factorial. 4 minus 2 is 2, 2 factorial. Times 2 factorial over 1 factorial. 1 factorial times 1 factorial over 1 factorial, 0 factorial. Keep in mind that 0 factorial equals 1. So what do we actually have here? What cancels out? The 4s. Oh, that 4 didn't. Oh, this is supposed to be 2 factorial. Dope. 4 factorial over 2 factorial, 2 factorial. This 2 factorial cancels out with 2 factorial, 1 factorial cancels out with 1 factorial, and 0 factorial is just 1, and 1 factorial is just 1. So we can just ignore those for now. Oh, I didn't want to ignore that one. So 1 factorial. So what do we actually get? You get 6 factorial over 2 factorial, 2 factorial, 1 factorial, 1 factorial. 6 letters, 2 Fs, 2 Es, 1C, 1O. And that's where that formula comes from. So two different ways to think about that. This is an ordering. We're dealing with orders. So this kind of thing generalizes orders. Generalizing combinations. What's a generalized combinations? You're allowed to repeat things. So suppose you have 5 questions on a quiz. Each one is worth 20 points. Each question has to be at least 2 points. How many ways are there to distribute the points among the 5 questions? So 20 points total in the entire quiz, right? So each question has to be at least 2 points. So the question becomes distribute 10 points to 5 questions. How many different ways are there to do that? Well, I've got 10 points. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points. And I want to think out, I've got 5 questions. So I could say, give these 2 to question 1, give these 2, say these 4 to question 2, give these 2 to question 3, this one to question 4, this one to question 5. So what does this mean? This means that question 1 is worth at least 2 points. Question 1 is worth 4 points total. Question 2 is worth 8. Question 3 is worth 4. Question 4 is worth 3. Question 5 is worth 3. So question 1 is 2 points plus these 2 points. Question 2 is 4 points plus the 2 points it has to be. Great. So that's how I can think about distributing 10 points to 5 questions. But no, once I've distributed the questions for points for questions 1, 2, 3, and 4, I already know how many are 5, right? Because I've got 10 points total. If I've distributed points to questions 1, 2, 3, and 4, then I've got, then I know how many are actually distributed. So what do I have to do is, the way I think about this is there's my determination. I have, think about this, 10 points split among 5 questions, except I don't need to think about the 5th one because once I've determined the other 4, then I know how many are in the 5th question. So what do I have here is actually I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points, and 1, 2, 3, 4 dividers. So where I put the dividers gives me a different choice of arrangements of points, right? So if I have 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of these, and I put one divider here, one divider here, one divider here, one divider here. And these are the points for question 1, question 2, question 3, question 4, question 5. So really, if you look at this string, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 different symbols, all of which are either places to put a point or a divider. And the question is, in this list of 14 places, where do the 4 dividers go? So there's C14 ways to distribute the points among the 5 questions. This is a very similar question. How many solutions are the equation x1 plus x2 plus x3 equals 15? If x1, x2, and x3 all have to be integers, let's make this 4 since there's just not quite so many cases. X1 is between 2 and 4, x2 is bigger than 1, and x3 is bigger than 2. So we have 3 cases. Case 1, x1 equals 2. Case 2, x1 equals 3. Case 3, x1 equals 4. So in case 1, we need x2 plus x3 equal to 13. In case 2, you need x2 plus x3 equal to 12. In case 3, you need x2 plus x3 equal to 11. Okay, but there's a restriction here. x2 has to be at least 1, x3 has to be at least 2. So if we say x2 is here x2 is y2 plus 1, x3 is y3 plus 2. Great, so in terms of y2 and y3, well, x2 is y2 plus 1, x3 is y3 plus 2, so that's 3 points we've already accounted for. So y2 plus y3 has to be equal to 10. Here, y2 plus y3 has to be equal to 9. y2 plus y3 has to be equal to 8. So this problem comes down to the question of how many solutions are there to this, how many solutions are there to this, how many solutions are there to this. So if I look at y2 plus y3 equals 8, I think there are 1, 2, 3, 4, 5, 6, 7, 8 spaces and 1 divider. So it should be C91. So there should be 9 ways in order to add 2 numbers together that are between 0 and 8 and to get 8. And why is that? Well, you could go 0 plus 8, 1 plus 7, 2 plus 6, 3 plus 4, 4 plus 3, 5 plus, no, 4 plus 3, I missed a number there. 5 plus 3, 4 plus 4, 3 plus 5, 2 plus 7, 1 plus 8, 2 plus 6, 1 plus 7, 0 plus 8. There we go. So there's my 9 ways to add 2 numbers together and get 8. Right? And so essentially what I've got is I've got 8 units divided by a plus sign. Right? I've got 0 on one side, 8 on the other, 1 on one side, 7 on the other. So I've got a string of 9 symbols, right? My 8 units and my plus sign. And I just want to know where's the plus sign. There's one place to put the plus sign out of the 9 possible positions. So we have 9. And this is 10 and this is 11. So there's going to be, what, 30 possible solutions to this problem. So we have this following result. If you have n objects, you're choosing k without ordering them, but with repetitions. You have the number of ways to do this is given by this formula. C n plus k minus 1. So if I've got 10 objects and 5 questions, 10 plus 5 minus 1 is 14, and then n minus 1 is 4. And k is 4 of them. So, and that gives us this little table. You're making things in order. Permutations have no repetitions. That allows you repetitions. Unordered selections. Let's give it that for